by relativity. So I find myself as a mere biologist baffled by some of the things that physicists talk about. And just to throw out one example, in the expanding universe, we are told, and I have to believe it, that everywhere is, as it were, the same as everywhere else. There's no one place which is the edge of the universe. How can that be?
Well, Richard, first of all, you said you're told it, so you have to believe it. I will never require you to believe anything.
Good for you. Well done.
It will only ever be about how compelling is the evidence to you. But you started with our sensory organs and landed in the expanding universe. Can I take us back to the organs and then perhaps land in the universe?
Yes.
The urge to think of our senses as being powerful or good is strong because first, that's all we have. Second, we like having nice thoughts about ourselves rather than miserable, depressing thoughts. So we're prone to walk around celebrating, for example, the power of sight or of taste or of smell. When, of course, when you really want to smell something, you bring a dog and they smell. Their nose smells much better than your nose smells. I was going to say the dog smells better than you, but that would insult you. So their nose smells. So we already know that our senses are feeble, and we reach to other creatures in the animal kingdom, cite them as having better examples of our sight, of our taste, of our smell. But little did people know much before a century and a half ago that our sense of vision is limited only, as Richard said, to the colors of the rainbow. And it's quite extraordinary to realize that, for example, beyond red, there's something called infrared. And beyond infrared, there are microwaves. And beyond microwaves, there are radio waves. Go the other direction, you go beyond violet, ultraviolet. Beyond that, X-rays, gamma rays. Energy goes up as you approach gamma rays, with dramatic consequences if you have gamma ray exposure, by the way. Of course, we all know you turn big, green, and ugly, as the Hulk had experienced. But the point is, the visible light part of that spectrum is a tiny slice, and the universe doesn't only communicate with us through that slice, as we had taken for granted for so long. Most of the history of the telescope, which is itself an extension of our eyes, extended the power of our eyes, but not the range of our eyes. And it wasn't until we first understood maybe we're missing something in the 19th century. The 20th century came decade by decade, new telescopes in each newly discovered band of light. And only then did we learn about black holes in the universe or remarkable, violent forces operating in the centers of galaxies discovered by radio telescopes. So, yeah, we're practically blind out there, and it's humbling, by the way, but that's the whole point of the methods and tools of science, to not only extend your senses in the domain in which you understand, but to take them to places they've never been before. On top of that, we have methods and tools that detect things that are not even extensions of your senses. You have no clue what the magnetic field is around your body right now. You have no clue whether or not you're being bathed in ionizing radiation right now. You'll eventually figure that out as limbs start falling off, but while it's happening, you actually don't know. And there are other things that are more subtle, like polarization of light. So when I think of the scientist's toolkit, especially the astrophysicist's toolkit, it's all about how many different senses can you bring to bear, technological senses can you bring to bear on decoding the universe. One of the things we've discovered, now getting to your horizon question, we look around the universe and it looks like we're in the center. What an ego-supporting concept that is. You can either go around continuing to think that, feeling good about yourself, or study the problem and learn that in an expanding universe where the speed of light is finite at 186,000 miles per second, forgive me using miles per second.
I prefer miles.
You do? You got that on tape? You prefer? An Oxford professor.
No, it's true. Nobody talks about kilometers in Britain.
Oh, good. All right. So we share not only most of our language, we share miles still. And inchworms, what do they call them? They're not centimeter worms, right? They're inchworms.
We don't have that sort of stuff in Britain. That's Europe.
Of course, Britain is not Europe, as we're constantly reminded. That's why here we have the English breakfast and the continental breakfast.
Yes, that's right.
They're very different breakfasts that you can order here. So this horizon problem is actually quite simple. And rather than explain the full-up nature of it, let me just give a simple example that is entirely analogous. When you're a ship at sea and you look out, your horizon in every direction is the same distance from you. It depends on your height above the sea level. That's why ship decks are high. They see farther beyond the curvature of the earth than you do just standing on the main deck. So your horizon is a perfect circle centered on you. You can conclude that is the extent of the entire earth, or you can imagine, suppose I'm in another spot. Well, that horizon is still true for whoever happens to be in the middle of it, but now you've moved to a new place, and you will see a horizon corresponding with that spot. And so everybody has a horizon at sea, yet no one at any time is thinking that that's the full extent of the ocean or the full extent of the earth. We have a horizon in the universe, so does the Andromeda galaxy. The galaxies with names that look like phone numbers. If you travel to those galaxies, they will see the edge of the universe now in 3 dimensions, in every direction, at the same distance from them, just as we see for ourselves.
That does it for me, provided that the horizon is that which we are capable of seeing. I could follow that if you said that for any part of the universe, the horizon is the bit before the expanding universe has disappeared over the horizon.
Yes.
Which means it's no longer visible.
Yes.
No longer, but it's still there, even though we can't detect it.
It's true with the ocean when you're at sea.
Yeah, but is anybody on my side here?
You want it to be a harder problem than it is. I'm just simply saying, so here you go. The radius to our horizon is about 14 billion light years.
Got it, okay.
Okay?
Yeah.
If we sat here or returned to this spot 1 billion years from now, that horizon will be 15 billion light years away.
Yep.
It's actually an expanding horizon because the light from 15 billion light years away, will have had time to reach us. Right now, it's still en route.
Yeah, I have no problem with that, but beyond the 14 billion year...
The problem is the universe wasn't born yet.
Yeah, okay.
That's the problem.
I know.
Okay? So you can't see the universe before it existed.
So why doesn't somebody...
Invent a kind of telescope that can?
No. Okay, I'm getting out of my depth here. Let's get back to...
No, just to clarify.
Okay.
Just to clarify. So it takes light time to reach us, and the universe hasn't been here forever. When you combine those two facts, you get an edge of the universe. And so the universe has been here for 14 billion years. The farthest thing that could send us any information is 14 billion light years away.
I get that, but what about the guys who are on the edge of what we can see? How can they see beyond the other side?
Oh, because here's an interesting point. Okay. We don't know whether or not the entire universe is infinite.
Okay.
And our horizon is, the universe could be twice our horizon or infinitely larger than our horizon. Same with the ocean. You don't know how much bigger the ocean is than your horizon is. You can keep sort of wandering around. Maybe you'll hit land, as we've done, of course. So now you go there. If the universe is really, really big, that will be the center of their own horizon. And whatever the age of the universe is for them at that time, that will be the radius to their horizon.
Yeah, okay.
Over the past decade or so, we have seen out to the very limits of the observable cosmos. We've mapped its largest structure, the cosmic microwave background, the oldest light in the universe according to the standard Big Bang model of cosmology. What we have discovered is shocking.
The colors we see here in the cosmic microwave background map are kind of like a weather map, showing hotter and colder, showing how hot the radiation is that's coming from different places. This is just radio noise from our own Milky Way galaxy. We're supposed to see the same number and types of hot and cold spots in all directions, because there is no up in the universe that's special. And that is sort of what we see, except not quite. This map here can be decomposed into what we call multipoles. You blur out all the little spots, and you still have the bigger ones remain. Like here is an area with a lot of blue. So when you smudge it, this will be one single big blue spot. Whereas when I smudge this, where there's a lot of red and yellow, it'll be one big blurry hot spot. On the very largest scales, we see a pattern of really big hot and cold spots which line up around a special axis, which has been dubbed the axis of evil. And it's quite puzzling. Why is there a special direction in space?
This background radiation should be isotropic. It should define no special direction in the universe, and certainly not one related in any way to us.
There is, I think, a real possibility that the axis of evil and other strange things we see in the large scales of the cosmic microwave background are a hint of something really big.
One of the fundamental principles of cosmology is the Copernican principle, that we believe that the Earth does not occupy a special position.
When you look at the cosmic microwave background, it's uniform in all directions, which is what you'd expect for the universe, in fact. Another bit of evidence that there really was a Big Bang. But there have been some anomalies.
There's one point about it that the radiation isn't exactly isotropic, it's almost.
So they send up the satellite and they find out, wow, there's anisotropies out there. It's not smooth. Not only did they find anisotropies, what they found was that these anisotropies, these disturbances, these temperature disturbances throughout the universe were all pointing to the Earth.
The cosmic microwave background alignments do not define a center, but instead an axis, a preferred direction spanning the entire universe. The fact that these alignments are correlated to our own neighborhood is highly difficult to explain from within the assumptions of Big Bang cosmology. The dipole, which is aligned with our equinox, is usually attributed to a relative motion between our solar system and the cosmic background itself. However, the quadrupole and octupole alignments are also with respect to the ecliptic, the plane of the orbit of the planets around the sun.
Some people have actually suggested that there's structure in the cosmic microwave background radiation that's related to where the Earth is and how it's going around the sun, which is crazy, because we're nothing special.
Yet, there is this very special direction imprinted in these baby pictures of the universe, and it's pretty clear now, since many different groups have hammered at this, that it's real, it's in there in the data. What's much less clear is what it means.
We have a conflict between what is a well-established mainstream thought and what is the testimony of experiments.
But when you look at the CMB map, you also see that the structure that is observed is, in fact, in a weird way, correlated with the plane of the Earth around the sun. Is this Copernicus coming back to haunt us? That's crazy. We're looking out at the whole universe. There's no way there should be a correlation of structure with our motion of the Earth around the sun. The plane of the Earth around the sun, the ecliptic, that would say we are truly the center of the universe, unquote. That whole cosmic microwave background is pointing to us, this tiny little space in the universe, and that happens to be where we live.
The strangeness of the alignment of cosmic microwave background with the ecliptic and equinoxes of Earth led many cosmologists to believe that the Planck satellite mission would finally show these alignments to have been a mistake, a foreground that wasn't subtracted properly, or a scanning beam anomaly in the WMAP telescope. Would the axis of evil turn out to be real? Finally, on March 21st, 2013, at the headquarters of the European Space Agency in Paris, the results of the Planck satellite mission were publicly released.
Today we are going to present to you the cosmic microwave background. Progress towards the future by understanding the past.
This map is a goldmine of information.
The stakes were high. If Planck were to confirm the existence of the axis of evil, it could mean the foundational principle of modern cosmology, the Copernican principle, is wrong. Planck was expected by many to show instead that the strange CMB axis of evil was nothing more than foreground contamination or a scanning beam anomaly somehow missed by the WMAP team. We flew back to Boston to interview Max Tegmark at MIT. We asked him whether his discovery of the axis of evil had been confirmed or debunked by Planck.
It was just so exciting. I'm standing there shaving at 5 in the morning while I'm watching George Eustathio on the live feed press conference. And when the first image comes up on the screen, I line it up with this cleaned image of the data that we had made way back in the past. And it all matches. This spot matches this spot, this one matches this spot. And I'm thinking to myself, whoa. This is so awesome. And the axis of evil is obviously there because all the big spots are in the same places. So all these puzzling anomalies have survived.
But what about the alignments with the ecliptic and equinoxes, which Lawrence Krauss had said would mean we were really the center of the universe? We asked Max Tegmark if Planck's results had convinced him that the axis of evil actually was aligned with our ecliptic and equinoxes.
I've really changed my opinion in a major way and how I feel about our place in the cosmos. For many years, I was feeling more and more insignificant. We realized that we humans were just living on a small planet in a solar system, in a galaxy, in this universe. We just kept getting smaller. Then we realized we're not even made of the majority kind of substance, dark matter and dark energy. And then we realized that we're also very brief. Our 100-year lifespans, compared to the 14 billion year age of the universe. So how could we possibly be significant? But I've really completely changed my mind, and now I actually think we're very significant.
So now we're in a position to look at the entire microwave sky. First, we introduce the multipoles. The dipole, usually attributed to a relative motion between our local system and the CMB itself. The quadrupole, the north and south ecliptic poles, and the spring and fall equinoxes. The S-shaped line represents the plane of the ecliptic, the plane of the orbit of the planets around the sun. Notice how it neatly divides warm and cold sections of the CMB map. This is our first hint that something very unusual is going on. Now we transform our Molveda projection into a sphere and rotate our universe so that the S-shaped line of the ecliptic becomes the dark line across the center of the sphere. This plane, lying between the warm and cold areas of the CMB, will become the grid along which we fly through the entire visible universe. From the point at which space first becomes transparent and structure begins to form, through the Virgo supercluster, and finally to our own Milky Way galaxy. As we enter it, amazingly, we arrive at our own local neighborhood. Our sun, and finally, our home. So does this mean that the pendulum has started to swing back away from the Copernican principle? Could this, in fact, be Copernicus coming back to haunt us?
Please, sir, we've done what you told us. We brought you the broomstick of the Wicked Witch of the West. We melted her.
Oh, you liquidated her, eh? Very resourceful.
Yes, sir. So we'd like you to keep your promise to us, if you please, sir.
Not so fast. Not so fast. I'll have to give the matter a little thought. Go away and come back tomorrow.
Tomorrow? Oh, but I want to go home now.
You've had plenty of time already.
Yeah. Do not arouse the wrath of the great and powerful Oz. I said come back tomorrow.
If you were really great and powerful, you'd keep your promises.
Do you presume to criticize the great Oz? You ungrateful creatures think yourselves lucky that I'm giving you audience tomorrow instead of 20 years from now.
Oh.
The great Oz has spoken.
Oh.
Pay no attention to that man behind the curtain. The great Oz has spoken.
Who are you?
Oh, I am the great and powerful Wizard of Oz.
You are? I don't believe you.
No, I'm afraid it's true. There's no other wizard except me. You humbug! Yes, it's exactly so. I'm a humbug.
Oh, you're a very bad man.
Oh, no, my dear. I'm a very good man. I'm just a very bad wizard.